Hi, my name is Keith.
My name is Van.
I'm Prabhat.
I'm Rogelio, and today we're going to talk about the data link layer.
The OSI model, or Open Systems Interconnection Model, characterizes and standardizes the communication functions of telecommunication and computing systems. It separates a communication system into 7 layers. Each layer serves the layer above it and is served by the layer below it. The 7 OSI layers in order of lowest to highest are physical, data link, network, transport, session, presentation, and application. These 7 layers can be further broken down into media layers: physical, data link, and network, and host layers: transport, session, presentation, and application. The first layer, called the physical layer, defines the electrical and physical specifications of the data connection. The physical layer defines the relationship between the device and its physical transmission medium. It is also responsible for the transmission and reception of raw data. Transmission modes can be simplex, one direction of transmission, half duplex, only one direction allowed at a time, and full duplex, two-way simultaneous transmission. Because of the abundance of available hardware with widely varying characteristics, the physical layer is regarded as the most complex layer in the OSI architecture. The second layer, called the data link layer, provides node-to-node data transfer. Its main objective is to communicate with the physical layer and the network layer. It also detects for errors and controls the data flow to ensure that the data can be handled. As it is implied in its name, it links between 2 directly connected nodes. It can transfer data between adjacent network nodes in a wide area network or between nodes on the same local area network segment. The data link layer provides the means to transfer data between networks and can also detect and correct errors that can occur in the first layer, the physical layer. The data link layer also mediates the use of specific mediums. When 2 devices try to access the same medium simultaneously, a frame collision will occur. Data link protocols specify how devices detect and recover from frame collisions and may provide mechanisms to reduce or prevent them. The data link layer connects the network layer to the physical layer by responding to service requests from the network layer and issuing service requests to the physical layer. The data link layer can also be divided into 2 sublayers: the media access control, or MAC sublayer, and the logical link control, or LLC sublayer. The MAC sublayer is responsible for controlling how devices in a network gain access to medium and permissions to transmit it. LLC sublayer is responsible for identifying network layer protocols and then encapsulating them, and controls error checking and frame synchronization. The LLC sublayer multiplexes protocols running above the data link layer and provides flow control, flow acknowledgement, and error notification. It also provides addressing and control of the data link layer. The LLC sublayer specifies which mechanisms are used for addressing stations over the transmission medium, and it controls the exchange of data. The MAC sublayer is responsible for determining who is allowed to access the media at a specific time. Media access control can be broken down into 2 forms: distributed and centralized. A distributed network is a half-duplex network in which transmission can only occur one way at a time. A centralized network allows all devices to communicate with a single relay node rather than each other. Frame synchronization is the process in which a specific set of bits is identified as frame alignment signals and separated from the data. There are 4 means of frame synchronization: time-based, character counting, byte stuffing, and bit stuffing.
Data link layer is the second layer of the OSI layered model. This layer is considered as one of the most complicated layers because its complex functionalities and liabilities. Data link layer provides the upper layer as the medium to communicate while hides the details of underlying hardware. Functionality of the data link layer is usually split into logical sublayers, or the upper sublayers, which is termed as LLC, that interacts with the network layers above and the below sublayers, which termed as MMC, that interacts with the physical layer below. Here I'm going to focus on logical link layer. Logical link control. LLC defines the functions to be needed for establishment and control of the logical links between local devices in the network. Therefore, LLC deals with protocols, flow control, and error control. Flow control. Flow control stations on same link may have different speed or capacity. Data link layer ensures flow control that enables both machines to exchange data on an equal speed. Two types of mechanisms can be set up ensure to control the flow. The number one is stop and wait, and the number two is sliding window. In stop and wait, control mechanism enforce the sender after transmitting a data frame to stop and wait until the acknowledgement of the data frame is received. Sliding window. In this flow control mechanism, both sender and receiver come to an agreement to wait until specific number of data frames to be sent before acknowledgement to be sent. There is a possibility to lost or received corrupted the data frames while they were transferring to the receiver. In both of these cases, neither sender does not have any indication of data loss, nor does the receiver not receive the correct data frame. In such situations, both sender and receiver should have equipped with sub-protocols which help them to detect transit errors such as loss of data frame. As a solution for this issue, data link layer uses some error control mechanism to ensure that the data has been transferred accurately to the receiver's end. Error control mechanism can be implemented in two possible ways: error detection and error correction. Error detection. Errors are detected in the receiver's end by using the parity check method. There are two ways to make the error correction in the digital world, as backward error correction and forward error correction. In backward method, receiver detects the errors of the data frame and requests back to the sender to retransmit the data unit. In the forward error correction method, when receiver detected an error of the data frame, it executes an error correcting code to auto recover the error correction process.
Hello, today I will talk about the MAC layer, which is the second sublayer or data link, as Prabhat mentioned previous. MAC layer is a layer that determine who can access the media when used by many users, so you can avoid the conflict. And in MAC layer, there are many types, but today I will talk about pure aloha, slotted aloha, and token passing, and pure sense multiple access with collision detection. For pure aloha is very simple. It has no discipline, and it has the ability to allocate multiple access channels, and the frame is usually destroyed when collision happens. When the sender detects collision, you wait for a certain amount of time randomly and retransmit the frame. And with this method, we can utilize we can have an 80% throughput in the amount of work that computer can do in a given time or period. For slotted aloha, is a modification over a pure aloha. The time has to be 6 minutes, so that the length would be exactly same as the packet transmitted time. Every packet transmitted must fit into a slotted by beginning and end in a precise synchronous with the slotted segment. packet arrive to be transmitted at any given station must delay until the beginning of the next slotted. And for token passing, there are two types of token passing. The first one is token ring, and the second one is ARSNet. Token ring is a widely used protocol in local area network after internet. Token ring technology provides for data transfer rate either 4 or 16 megabytes per second. It is a collection of individual point-to-point link connecting each terminal which in the form of cylinder. The token is passed among the data comparator for a limited amount of time to release the data on a common channel. There are many variants of this mechanism. For quality, there are many variants of this mechanism. For the quality of service, token is passed for a long time to a particular node. Node with more data get a token for the longer time. And for carrier sense multiple access collision detection, there are two type 2 as a token passing. One is persistent and the second one is non-persistent. This one, carrier sense multiple access with collision detection, is a media access control method used most specifically in local area networking using other internet technology. When two nodes send a data packet at the same time it collide, when that happens, a jam signal was sent along in the wire so it can sense the collision. So the data will be stopped when collision happens. But the problem with this is that it only sense or detect when after the collisions happen, after it's already damaged. So it is need to be recovered. We can't know before the collision happen. And the two type of this is that one is persistent and the second one is non-persistent, as I mentioned in previous. The persistent is an aggressive transmission algorithm. When the transmitted node is ready, it sends the transmission media for idle and busy. If idle, transmit it immediately. If it's busy, send transmission media continuously until it becomes idle, then transmit this message unconditionally. For non-persistent is a non-aggressive algorithm. When the transmitted node is ready to transmit as a one persistent method, it sends transmission medium for idle and busy. If idle, it transmits immediately. Busy, then over a random period of time, while it does not send transmission media before repeating a whole circle. Afterward, it starts sending transmission media for an idle and busy again. This approach is used and result in overall higher media throughput. However, it has a penalty of longer initial delay compared to one persistent.
Now I'm going to talk about the protocols within the data link layer. First, I'm going to take a look at IEEE 802.3 standard, which covers Ethernet, and IEEE 802.11, which covers the wireless standards. First, the 802.3 standard, it governs the Ethernet speeds and physical media. The physical media of the Ethernet are started as coaxial cables. They consisted of UTP, which is untwisted pairs, and STP, which is shielded twisted pairs. One of the features of 802.3 is carrier sensor multiple axis with collision detection. This protocol makes sure that no Ethernet data frames being sent within the same network collide and cause a traffic jam within the data. The next IEEE standard is 802.11, which is a wireless. This one also has a carrier sense multiple axis, but instead of collision detection, it is considered collision avoidance because since everything travels through the air, there is no way that collisions could be detected. Instead, they are avoided. As we all know, 802.11 has a lot of different standards. It could be A, B, G, N, or even now AC. Back then, the first ones that started off were A, B, and G. AN and AC are in the 5 gigahertz frequency range, while BGN are in the 2.4 gigahertz frequency range. There's also 900 megahertz frequency range for covering longer distances. The larger the frequency, the more it can penetrate through buildings and materials like rooms, doors, windows, etc. Now I'm going to talk about the protocols that are within the data link layer. Now that we've covered what the main objectives of the data link layer are, which I will review real quick, they are to communicate with the physical layer, to communicate with the network layer, data framing, addressing, error detection, and flow control. So the first protocol we will look at, we'll go back to Ethernet. Ethernet has two addresses where it will contain the MAC addresses of a source and a destination. The CRC will cover the error detection that the data link layer provides. So as you can see in this diagram here, we can see the destination address and the source address, and then the data itself, and the CRC will go at the end to make sure that there was no data errors within. This could be parity, even, odd. Here's a diagram where it shows that Ethernet and the IEEE 802.3 standard crosses over between the physical layer and the data link layer. The next protocol we will look at is the stop and wait protocol. This protocol transmits a single frame at a time between the sender and the receiver. For this protocol, if the frame sends 0, then for it to make sure that it was received, the acknowledgement, or the ACK, as you can see in the slide, will have to send a 1 back. Once it sends that 1 back, it'll know that it is okay to send the next frame, and that frame will go to 1, and the ACK, or acknowledgement, would have to be 0. This is how it knows that there are no detections, no error detections. If, for example, if a frame sent a 0 and an ACK sent a 0 as well, or it never received anything, that frame 0 will be sent again until it is received. Another major protocol is a point-to-point protocol. It provides 33 mechanisms. Another protocol is a point-to-point protocol. It provides 3 mechanisms. The first mechanism is the framing method. This is for error detection. It makes sure that the packet has the right frames and the right bits. Another mechanism is a link control protocol. It establishes, configures, and tests data link internet connection. So when the physical layer goes up to the data link layer, and the data link layer is trying to communicate with the network layer, it'll establish that connection, it'll configure it to the right settings, and then it will test that data link connection and make sure that the connection is established and that it could handle what is being sent. So the link control protocol packets, or LCP, are sent out to make sure that the receiver could handle them and acknowledge them before communicating. And then the last mechanism goes hand in hand with the link control protocol method, which is a network control protocol. This will basically just negotiate which network layer is used.